Good morning, everybody. My name is Jason Fox, and today I'm joined by Germán Molina Carrasco with HOPU to give you an overview of how to expand your FIWARE system to use other third-party open source tools. In particular, we're looking at how to monitor measures using FIWARE and Grafana. So, in summary, today what we're going to do is briefly explain what Grafana is. Most of you probably already do use it or have come across it, and there's obviously more background reading on that. This is not designed as a Teach Yourself Grafana tutorial. There's plenty of Teach Yourself Grafana tutorials out there already. This is very much on the specific of how to connect our FIWARE system to Grafana, but we'll describe what Grafana is and what you can do and why you might want to use it. The important point here is that when you're creating a smart system, you're not going to be building everything from scratch. You're going to be bringing in open source databases. You're going to be bringing in third-party open source components. You're going to be bringing in FIWARE components. You're going to be bringing in your own custom components, and you need to set up your overall system so it is going to be flexible, and when you need to change based on customer feedback or maybe your scaling considerations, how you should do this so that you can keep your system working in a reasonable fashion. So the important point here is not so much this is FIWARE, this is Grafana, it's this is FIWARE, how do you architect a system which is able to offer syncs to a third-party system which is also expandable and flexible in itself. So we will discuss what the architecture is required around this system, what the various microservices you will need in the system or potentially need in the system, and how to get the data to flow as necessary. This will be covered in two use cases. The first one is going to be nuts and bolts of opening up the architecture, with the deep dive in the filling station dashboard, which will be using NGS-ILD. And then I'll be passing on to my co-presenter, Germán, who will be describing some real live use cases, because it's important to realize that the reason why people use FIWARE is that it's commercial software which you can actually build proper systems. And when you have real live customers who are paying for your systems, then they obviously will have requirements which will come in as time goes by, and you will need to respond to keep your customers happy. Okay, what is Grafana? Well, Grafana is a typically a monitoring tool. It's used by the DevOps community to come up with a lot of very dark graphs, usually dark mode. There's a light mode as well, but hey, this is DevOps. Everything by default is in dark mode, and you can create monitoring dashboards. You can connect to get hold of logging information. You can get hold of nice little dials which will show whether it's green or red or orange or whatever. You can see on the right-hand side some of the more complex graphing you can get. Now, importantly, this is open source software. It's licensed under Apache 2, which means that you still have got your own, there's a patent clause. So it means that if you have stuff which you are using which is clever and proprietary, you can still create patents around it. And it's flexible. It's you can have single ad hoc queries, which you might need to do to try and investigate stuff. Like most tools which are usable, it can't be fixed as saying, I must use this database, I must use FIWARE, I must use MongoDB, whatever. It has a multitude of data sources, and you can actually add your own custom data source to be able to read in the data. And obviously, there are a different variety of different visualizations you can add, and you can create your own. So the point here is that if you are going to pick a visualization or graphing tool, you shouldn't tie yourself in. You should keep the flexibility to be able to change things, because you know full well that your customer is going to want it displayed differently, or you'll come across a scenario where you need to do additional ways of displaying stuff. Now, on-screen visualizations in Grafana are driven by plugins, as you can see from the two links below. This is very similar to the say the visualizations you get in WireCloud, where you have widgets. And the same thing applies. There's a little bit of software which is used to get hold of the data, muck around with it, and display something nice on screen. Obviously, you would install these as part of your installation, a little bit of software, and then you're able to access them and be able to use them within your monitoring display. This means that you don't have to start from scratch every single time, but within the demo I'm going to give, I'm going to start from absolutely nothing. Sources and sinks. At this point, there are, I think it's 13, 14 default sinks and sources within Grafana. Everything from Prometheus, which will give you logging information. There's actually a tutorial online on how to get your Docker logs into Prometheus into Grafana if you're interested, through to a series of databases like MySQL or Postgres SQL. There are many more additional plugins. So you'll notice, for example, MongoDB is not in that list at the moment. However, you can get it direct from the Grafana data sources. Now, Grafana is able to read in data sources either time series or non-time series. Time series being a historical track of what was happening when. 30 seconds ago, my filling sensor was full. Now it is down to 80% full. Is time series. Whereas non-time series data, we're talking about the now, and that's very much where the context broker comes in. Context broker itself is going to be in a position where it needs to only hold the current information. So you won't be able to use a context broker directly as time series, but you may be able to use it directly as a non-time series mechanism. Moving on to a deep dive example, we're going to show how to get data into a system, which means that in this particular case, we're going to have an NGS-ILD context data coming out from our devices. As it happens, our devices are going to be on a smart farm. They will go into an IoT agent, which will obviously push out data into NGS-ILD, into an NGS-ILD context broker. So this means that we have a common interface. We have the context broker NGS-ILD interface for all the information we are gathering. The stuff at the bottom of the stack isn't particularly relevant to what we're doing here. We'll need to raise an NGS-ILD subscription, which means that we have a well-known format for how the data is coming out when the data comes through, and this will be able to persist data to time series data. It would be possible, if we wished, to raise the NGS-ILD subscription to a proxy, which means we would have an opportunity to manipulate the data before we proxy it on to Quantum Leap. We might need to do that in an NGS-ILD scenario if we wanted to do an expansion compaction operation, changing the values of the attributes before it reaches Quantum Leap. Now, Quantum Leap in this case is our data persistence mechanism. It is a separate component which is there purely for pushing data from one place to another. It is important that you must separate your concerns into multiple microservices. At this point, Quantum Leap is pushing to CrateDB. CrateDB, the latest version, again, is Apache 2. So again, you've got no issues on your open source database, and it is usable as a data source for Grafana. So you can see we're splitting up the various different elements into different different components, so that we can follow a chain of persistence. And finally, we'll get round to displaying the item on screen. Let's have a look at this in action. So I have a little I have a little tutorial which is running the various elements of my system. If we have a look at the Docker Compose, you'll notice that we have got, where's this thing? It's down. Grafana. We've got, when we are loading up Grafana as an other service, we have additional plugins which we are loading. We're loading in the Grafana map plugin, the clock plugin, the world map. This will become important when we go through later on in the system. Now, within Quantum Leap, it is saying I will be persisting out into CrateDB. So it's important. So you can see how the data will flow from A to B to C, and Quantum Leap is going to be our think in this case. Okay, so we've now got the smart farm up and running, and we've got some data coming in from our devices. There's no real need to know what the devices are. This is using ultralight, but it doesn't really matter. You've just got data flowing in to your context broker. You can see I've got pigs and cows moving around on screen, and I want to be able to track these in real time. We need to check to see that we've got the thing up and running now. In order to get data into Quantum Leap, you need to create a subscription. This is an NGS ILD subscription here, and we'll start off by showing uploading the filling stock. Now, it's possible to have a more generic subscription. This is just putting the stuff normalized NGS ILD format. And of course, you have your at context in there as well. This is just going to update the filling sensor. Let's see what happens. It's created a subscription, and again, let's do this the same thing for our animal locations. The animals have got type of device, and you can see that we are watching location, status, and heart rate. When I provisioned the devices, the filling station had a static attribute which also would have a location. When you're typically with a system based on FIWARE, you're talking about assets in the real world. It's therefore necessary to be able to locate these items in the real world, or potentially have something like a controlling asset, which is saying I am actually within building 1 or whatever. Now, this means that when you have stuff, you will be able to display a map with the locations on it. For the actual animal collars, it's a little bit different in that there is a device. Try and find it. There's a temperature sensor. Here we go. Device. There is a device service, and the service itself is passing in GPS location as a location. So it means that within the context broker, you've got a location. This should be persisted and read by our subscription passed on to Quantum Leap. As we can see, the filling sensor has been notifying this has been sent so many. This has been sent 9 times, and the other one has been sent so many times, and so on. If you have a large number of varying data, you'll need to throttle the values which are received. So this is going into Quantum Leap. Quantum Leap itself, see if we can see the logs. I've got the logs running. It's taking a bit of time to come up. There we go. Quantum Leap. Quantum Leap itself is receiving. You can see it's receiving the data. Now, there's a reason why when you set up Quantum Leap, you might want to have a Redis database in the front end, in that you don't want to overload your services. So at the moment, we're reading in several positions of cows or pigs, but you can also make requests to the system directly to ask for time series information. If that information has already recently been received, it may use Redis to get hold of the information rather than go for the database. So we can see what has actually been happening with our system by, say, retrieving the last the first 3 samples from our filling sensor. Let's see, is it actually sending you data for the filling sensor? It's thinking about it. So that doesn't appear to be oh yeah, we get no records found for the filling sensor because the filling sensor has not been. But what about if we were to look for cow 1 instead? And it's going to think about what's going on, and eventually it will get hold of some data. I've not found for cow either because I put the name wrong, I think. So you can also go direct to the CrateDB itself to do queries. This is effectively what the Grafana database will actually do. It's actually going to retrieve information direct from a table, which is going to be based on the NGSILD tenant or the FIWARE service name. It's called OpenIoT, and this one MT is just a prefix, and it will receive data for a specific type. Going on to Grafana. Grafana, first thing you'd need to do is to configure your data source. Now, the data source in question is not, it's a CrateDB data source, is not one of the standard ones you've got. However, it is the equivalent of a Postgres. So I need to get my values in there. So just a minute. Move that across back here. It's listening on the I'll call it crate. It's listening on the standard CrateDB host port. It's going to be called CrateDB because I'm running this within its own network. My database is OpenMIT. I have a user called Crate, and I have no password. Disable. So you can then test to see, can I actually connect to the data source? And yes, the data connection is okay. At this point, because we've actually got the data in our dashboard, we can say choose a visualization. You have a range of visualizations available here. Obvious one is to go for a graph, and the graph will give you a little wiggly line. At this point, you would need to connect your table to work out where we're coming from. Now, the time column which Quantum Leap saves is called time index. At the moment, for the NGS ILD data, it's actually taking the data of the subscription, but it should take the observed at. And then finally, if we go for an entity ID, column unknown, value is unknown. Now that's because it's not value. As I said earlier, you can transform from you can transform your data if you need to in a proxy before you receive the subscription. We call heart rate, isn't it? And we can actually give it an alias as well. I can give it an alias of value. And eventually, as you can see on the side of the screen, our cows and our pigs are now showing heart rate for the last 5 minutes. You can see that there's various spikes, and you can also see that the typical cows have got a lower heart rate than the pigs. The pigs have got just over 1 beat a second. Now, it is various visualizations are possible. If instead of getting a changing value on a screen, you can also format this as table data, which would then be displayable under a different sort of visualization. Let's add a couple of extra columns. Now, the location is standard naming for NGS ILD. It is preferred naming for NGS IV2. But the value which this particular plugin I'm doing wants to call it GeoJSON. And we also want to have various types. Now, entity type is what is called in the database by Quantum Leap, but it is actually the type attribute. And you can see nothing is happening here until I move on to the visualization, where instead of going for a graph visualization, I can actually go for a map panel. You can then see that my devices are being displayed as a map layer because I've got a different value thing. And indeed, if I move the screen up properly and display my screen, I can actually see that my values are coming into the system. Let's zoom in there rather than change the defaults. You can see that my cows are based in Berlin. Oh, apart from one of them which has been escaping. Now, this is the sort of information you couldn't easily get from the screen here, because you can't tell that one of these pigs or cows is actually in a completely different location to all the others. You need to choose the appropriate visualization to work out what's going on. You can, of course, also do things like thresholding. You could see what the values of the various heart rates are on the screen, or you could even add in colors. Sorry about that. So not only can you do the standard display on a graph, they're able to do additional real-life use cases. This is where I will pass over to my co-presenter, Germán, to explain what's going on. Germán.
Hello, everybody. I'm Germán from HOPU. And here I'm going to show you how we have put Grafana in the next level in order to be able to build solutions that are ready for our customer. As Jason has said, Grafana is really focused for DevOps, and if you give to your customer one application that is a little bit dark, they will not feel comfortable. And it seems that they have a very good skills, but for sure you will need to empower it in order to do more things that fit your application. For that reason, the tool that we have found more useful for the application are the custom data sources. I'm going to try to introduce you to how to build a custom data source. It will be a very light introduction because it will take us a lot of time, but I think that it will give you a good idea on what is going on and how to extend the data source that you want to build. Okay, like Jason has said, a data source is something that connects your Grafana with external sources or services. This will do the Grafana panels be able to interact with your services that you have built in an external application. The requirement for build a data source is Git in order to clone the template that Grafana provides to you, Node for build the data source, and you can build the data source using two different frameworks. You can use Grafana, AngularJS for Grafana version less than 7.0, but currently they are migrating to React. You can still use Grafana AngularJS, but it's recommended to start migrating to React. Okay, this example will be focused on AngularJS because I think that most of you will understand the framework, and it's pretty easy, and it's the version that we have currently developed. When you develop a custom data source, you have three actors. You have the Grafana panel that will interact with the data source. You have the data source itself that will translate the Grafana panel queries to the external service that you want to communicate. In this case, we are going to focus on a Orion Content Broker example, and you need the reverse way. When you have the response from the Orion Context Broker, you have to translate the response to a Grafana understandable format that in this case will be the table. Okay, let's put the focus on the Grafana panel query. The Grafana panel query is split in two sides. The config controller that contains all the information regarding your data source. What is that information? The URL, where you have to point the data source, the security, or even the HTTP header if you are doing an HTTP data source. And the query controller that has all the parameters that you want to pass to the Orion data source in order to build the query to the Orion Context Broker. If you clone the template, you will see an scaffolding like this. If you know the Angular framework, you know that you have two sides. You have the view side that is the current HTML when you put the view, and you have another side that is the controller, that in this case is the config.ts, is when you put the logic of the solution. Okay, by default, Grafana gives you these fields. You can put the name of the data source, the URL where it's pointing, the type of access is server. In this case, the frontend will use the Grafana backend in order to proxy the request. I highly recommend to use this because if not, you will have a lot of problem with the course. And Grafana gives you a lot of authorization, different authorization, like like basic auth, OAuth, and that is very useful when you have to integrate the Grafana with your security layer. In this case, we have added a couple more fields that is based on FIWARE, the FIWARE service and the FIWARE service path, in order to access to the scope of the entities, and a pagination limit in order to try to accommodate the number of entities that you can get in one query. Okay. Once that we have the data source configured, we need to fill all the parameters we need to build the query to the Orion context broker. You can find the files necessary in the partial, the view in the query editor, and the controller will be the query controller. In this case, we have implemented some requests that we will see very soon. And we pass to the query controller the FIWARE service path if you want to override the default one, if you want to filter by query type, or you want to get some entities or just some attribute and not all of them. Mostly the parameter that you need in order to build your query to the Orion context broker. Okay. Once that we have all the parameters needed, we are going to use this parameter to communicate with the Orion context broker. Once that we fill all the parameters on the Grafana panel, the Grafana panel will call to the query function. The query function you can find by in the data source TS. And this is a really example of the first level of a query function that, as you can see here, we extract the query data from the options. We have a factory class in order to get the Orion query. We pass the request and the params. Once that the Orion query is built, we just execute. When we get with this execution is the NGCI noise level data model. This is a simplified one. And now that we have our entity in our data source, we have to return to the Grafana panel a model that it can understand. For that reason, we have built a class that what it does is parse the NGCI format to a Grafana table format. As you can see, it's very simple. You only have to extract the case, the keys, and the values, and put it in like rows. The keys as columns and the values as rows. Okay. And this is what we have. I have a small demo. Okay, this is a simple dashboard that is querying to the data source. Let's see the data source. This has changes. We have here the Orion context broker data source that is pointing to our developed environment Orion. Access through the server. We have put basic out in order to not allow everybody to access to our context broker, and we have put some service and service path by default. Okay, if we go back to the panel, we have seen here the world map. It is the current one that we have put in our customer solution that we will see after that. Is the city of Valencia. We can see how many devices are in this service path, and we can change for another one. In this one there is only one device, and we can see on the table what is inside also the FIWARE scope that we are querying. If we go to the query controller and view, here is the parameter that we can fill in order to request to the Orion context broker. We can see here that we can request for entities, for subscription, and many things that we have implemented. We can also filter by entity type. We have alerts. We have also noise level observed, devices, or we can query for all of them. In this case, device is good enough. Okay, we can query for the entities that we are filtered by entity. If we put alert, it will show us all the alert in order to ask only for one specific entity. Okay, devices, and we can also filter by attributes. We can ask for all of them, or we can just filter, for example, for analyze, and it will show us the alert. Okay, it's a very simple example, but I think that you can have an idea of what can you do, or the power of these tools. Indeed, this is our development environment of our product. This is a noise solution that we are developing in order to deploy it on the city of Valencia. It will be deployed in a couple of months. Here we can see that we are using also the same data source for some panels. It's Orion noise data source. Here we can select different devices, and the data source will interact with the Orion context broker. Okay, and what we find more powerful of this solution is that this client requests us that all the interaction through the FIWARE platforms should be done directly from the solution. They don't want to go to the FIWARE platform and interact directly. They want all the interaction from the same vertical. The FIWARE platform is deployed by Telefónica, so it is one of the goodness of FIWARE, that we can deploy a solution in any FIWARE platform that it will work. And thanks to the Orion data sources, we can do further upgrade of the devices. Even we can change the configuration, the sample time, reporting time, reflection settings, we can configure all the connectivity, and so on. Sorry for that. And other thing that we have implemented is an IoT agent data source that allow the client to provision devices directly to the IoT agent from the vertical of the noise platform. This vertical is compatible for any FIWARE-ready device, so they can integrate the device that they want. Theoretically, without our help, but the most common thing that happens is that they call us in order to help us to integrate or to add a new device. Okay, last thing that I would like to show you is that at the beginning we have a lot of not problem, but we want to customize Grafana, and we try to add our custom theme inside the service, and it's like a pain of the neck. It's horrible because you have to modify the files, you have to build Grafana again, you have to build your own Docker file. If you have many instances of Grafana deployed in different places, you have to grab all of them. And we try to find a simplest way to make Grafana without have to build our own Docker image each time. So what we have done is a really tricky, a simple way, but it saves us a lot of time. What we have done is clone the official repository of Grafana, and inside the inside the themes, you can find the default one. You can modify these themes, the light or the dark, the one that is close to the style that you want to achieve, and build the Grafana project. It will generate the Grafana theme TCS. Be careful and check out that you are modifying the same version that the Grafana that you want to modify, because this UUID is based on the version of Grafana. And then that you have the build CCS, you can replace it using the Docker compile file, or what we do is we serve it behind a proxy, because we have many instances that use the same style, and we can change all the style of the instances just using the same CSS. You lose the file theme because you modify it, but it will save you a lot of time. Okay, this is all from my side. Jason?
Right. You've already seen the two demos, either via a database or directly. I'm now going to briefly say how to get the style so that your customer will actually follow their brand guide. Now, if you look at the screen at the moment, you will find there's 4 different websites which are coming from FIWARE. You've got a GitHub, you've got Reddit, you've got Read the Docs, and you've actually got the real FIWARE in the bottom right-hand corner. However, they all look as if they are coming from the same organization. The reason behind this is quite simple. This is how you get phishing attacks. There are not very many elements you need to change in order to make something look approximately following the customer's preferred look and feel. So 90%, 80% of the work is done by 4 elements. You will have noticed that if you look on the texts, you'll find that there's headers are heavy and have got this black line beneath them, and the font is not the usual Arial font. You can change this quite easily by importing a web font whilst you're getting hold of the information, and this gives you confidence that this is a FIWARE website. Now, again, if you have the appropriate colors, and obviously your brand book will show you what the appropriate colors are. In FIWARE, you can see these blue, cyan, and grey. You will notice on the earlier in the presentation there was no yellow. There was no yellow until we reached the slides from HOPU, where, of course, their logo has got yellow as one of their primary colors. So going back to the FIWARE sites or spoof sites, you can see there's absolutely no yellow on the screen whatsoever, because it's easy to spoof. Finally, obviously, and this is the simplest one, but it really gets customers, they place a lot of importance on having the logo on there somewhere. Logo obviously goes to the top right hand side, and therefore display it prominently, and you'll end up with happy customers. I came up with the phishing websites for FIWARE in approximately 20 minutes, half an hour, and you can see it's not perfect. You can see, for example, the logo on the Reddit version is slightly too large, but it's good enough, and this appears to be coming from a single organization. So, in summary, Grafana reads from a data source, which can be one of many different data sources, and displays information onto a panel. The important point for FIWARE systems is that you must somehow create data into a data source which it is able to read. All of the panels can be and data sources are defined by plugins and configuration of those plugins. You saw various things being changed when you're trying to connect, and you can get hold of plenty of plugins. You can even get hold of alternative NGSI v2 plugins, for example, on the Grafana marketplace, plugin marketplace. And if that's not good enough, you can create your own stuff. There's a nice little PDF report, which Germán didn't show, but again comes from the HOPU organization. You can get hold of a nice alternative map plugins and so on and so forth. To display NGSI data, you must sync and have an appropriate sync. And the sync, if as necessary, is going to be either taking your NGSI data directly or via a time series database, as shown in the farming demo. And finally, for a unique look and feel, customers will put a lot of emphasis on having their viewpoint on their website. It's not difficult, it's simple HTML and CSS changes. So thank you very much for bearing with me today. All that remains is for me to hope that you've learned something, and hope you enjoy the rest of your day.